Besides the ambiguity of how to define the modified divisor, Jefferson's method also gives some issues in terms of how that rounding ends up in practice. That in 1832, for example, Jefferson's method, which was still used at the time, said that New York was set to receive an apportionment of 40 seats in the House of Representatives, despite the fact that from the standard quota, it was meant to get 38.59. And this meant it violated something called the quota rule. What the quota rule says is that the seats allocated should be either the upper or lower quota, either the amount rounded down or the amount rounded up, where Hamilton's method by design will always fall into that, but because of the fuzziness with the modified divisor for that modified lower quota, doesn't always happen with Jefferson's, and in particular, it's less likely to happen for very populated areas that his method should favor. So in 1832, it was set to be phased out, wouldn't get removed until in 1832, it was set to be phased out. In 1842 was when it was actually replaced, because these things run on sort of a 10-year lag time for how they are chosen, where one of the proposed ideas was put forth by John Quincy Adams, who essentially said to take Jefferson's method and deal with rounding up instead. So there, what you want to do is find the modified divisor D such that each group's modified quota is rounded up to the nearest whole number, where the sum of the quotas is the number of items to be apportioned. Then the modified quotients are rounded up and called modified upper quotas, where we apportion each group in terms of its modified upper quota. And to see this in practice, we're going to call upon that same example from before with the buses. It'd be quite nice if you're setting up a rapid transit bus line, so we're just going to have to content ourselves with getting to see how we could do it effectively in a hypothetical example. Anyway, for this, when we're dealing with the modified upper quotas and the modified divisor from Adams's method, what would happen if we take a divisor with the value D equals 512.7 is we would take each of those passenger values and divide it by 512.7. So we divide 4360 by 512.7, 5130 by 512.7, 7080 by 512.7, 10,245, 15,535, and 12,650, each by that 512.7. So we would get modified quotas of 8.5, 10.1, 13.81, 19.98, 30.30, and 44.18, which we would round up every single time because that's how the modified upper quota works, to 9, 11, 14, 20, 31, and 45 for a final apportionment there that gets us to the appropriate value of 130. Where this should make sense because our standard divisor, as we mentioned the last time, was 500, and because we are rounding up at each step here, we would want something that is a little bit bigger. So that 512.7 fits a little bit better, but the book would have had you sort of guess and check your way to that value, which again, I think is just silly. If we don't have a fixed formula, I don't really like giving that sort of stuff as examples for you guys because it's just not that interesting to work through these things in that way. It's better uses of your time on other things. Which, speaking of better uses of time, Adams's method wasn't taken either. He put it forth in 1832, but wasn't that popular as well. And you can see why it might not have been quite as popular there, because you're taking something like 10.01 and rounding that up to 11. So whatever state B is getting quite some preferential treatment there. And obviously that's not ideal for basically the exact same reason Jefferson's would be, except kind of in reverse. So his was scrapped, and the one we ended up taking, the one that ended up pushing forward, was Webster's method, which over the next 50 or so years would kind of oscillate between that and Hamilton's, but that's history. For now, let's actually look at Webster's method in practice.